this page, we're going to talk about the number of solutions a system might have. So far, all we've talked about is systems that have one solution. And we've said, okay, how can we solve? How can we get this one solution? We can graph them, and it's this point right here. We can use elimination, we can use substitution, and we can find this one solution. And that is what we have talked about so far. But there's these other two possibilities, which is that a system doesn't have a solution. So, and I'd actually like to look at the real life example first. So for example, there are two trees on a farm. One is 10 feet tall, the other is 13 feet tall. They both grow 2 feet per year. Now, because they're both growing at 2 feet per year, they're never going to be the same height, right? This one is always going to be 3 feet taller, right? This one's going to grow 2 feet. This one's going to grow 2 feet. Then they're going to be 12 feet and 15 feet tall. They'll never be the same height. So this is a real life example of a system that doesn't have a solution. The trees won't be the same height. The same is true with these lines, right? This line is down here and this line is up here, and they will always stay that way. They are parallel, right? These lines, when we're looking for a solution of a system, it's where the lines intersect. These lines don't intersect, and they won't. Okay, so this is an example of a system that has no solution. Now let's say you're using substitution or elimination. What you'll get at the end, instead of getting something like x equals 5, you'll get something like this. Well, this is just an equation that's not true, right? 0 does not equal 6, 3 does not equal 8. And so you'll realize like, oh, this system doesn't have a solution, right? And what it looks like in equations is an equation like this would be in slope-intercept form, where they have the same slope, right? They have the same slope and different y-intercept. And what that creates is parallel lines. Like if you think about this, right? This is the equation from this situation. This tree will start at 10 feet and it will grow 2 feet per year, and it will grow and grow and grow. And this tree will start at 13 feet and it'll grow 2 feet per year, and it'll grow and grow and grow, but it'll always be that 2 feet taller than the other tree. Okay, when they're both in standard form, they often look like this, right? Remember, this is ax plus by equals c. And what you might notice here is that if I just multiply this equation by 2, right, I would get 4x plus 2y equals not this, right? They have a different c value. And the reason that this is the case is that if you were to rearrange these into slope-intercept form, they would have the same slope and they would have different y-intercepts. Okay, again here, if you have something like this and you wanted to know, oh, how many solutions does this have? You would just rearrange this into standard form, right? You'd subtract 3x from both sides, you'd divide by -6. You would get two equations that have the same slope, different y-intercept. That is no solution. Okay, these are lines that look like this. They will never meet on the graph. Now, here's the other possibility. Not only is there a solution, there's a million solutions, a billion solutions, there's infinite solutions. These are two lines that sit on top of each other, right? You can see there's one line right here, and there's another line right here. So this point is a solution, and 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 so on forever and ever and ever. Okay, so for example, if I tell you that Jenny buys 2 shirts and 1 pair of pants for $50, and Maggie buys 4 shirts, right, twice as many shirts and twice as many pants for twice as much money, that actually doesn't give you enough information, right? These shirts and these pants could actually cost anything because this is just twice as much as this, right? So that's an example like here, right? She bought 2 shirts and 1 pair of pants for 50, 4 shirts, 2 pairs of pants for 100. These are equations that if I were to graph them, they would look the same on the graph. These are the same equation. They are the same. They have the same slope. They have the same y-intercept. They are the same equation. They will just sit on top of each other. If I take this equation and I move it around and I rearrange it to look like this, it will be the same. Okay? These two equations are the same and they sit on top of each other on the graph. Okay? And if you were to solve it using elimination or substitution, you would end up with something like this. Well, this is true, but it doesn't matter what the x value or the y value is. This is just always true. Okay, now what we have seen so far when we're talking about systems is something like this, where you get an x value and a y value, right? So for example here, like one tree might start shorter but then grow faster, so at some point they're the same height. And what we see with anything that has one solution, these are going to have different slopes, right? Here, the slopes are the same, right? Either they were exactly the same line, same slope, same y-intercept, or they were parallel lines, same slope, different y-intercept. We can tell that if something has different slopes, we right away know that that is going to be a system that has one solution. Okay, so you're going to use this page of notes on page 17, and you can use this space if you need it to do two activities in IXL.